Welcome to Gold Coast Insider, where we bring you business insights, stories, opportunities, and forecasts from movers and shakers across the Gold Coast. I'm your host, Estella Rodiguero. I'm CEO of Regional Development Australia Gold Coast. My guest today is Dr. Stefanie Feih. Now, Stefanie is an engineering professor in advanced manufacturing and 3D printing at Griffith University. She is the director of the Additive Institute, which is South East Queensland's leading institute for research and design of medtech devices such as surgical guides, implants, artificial hearts, satellites, and marine components. Stefanie has a passion for sustainability and recycling of materials. She received a PhD from Cambridge University and a master's from Cornell in the US, but is originally from Germany. Stefanie is ranked in the top 2% of scientists worldwide in the field of advanced manufacturing and materials. She lives right here on the Gold Coast with her husband, and she has a son as well who goes to school here. Welcome, Stefanie.
Hello, Stella. It's really great to be here with you.
Yeah, good to talk to you. Like, I've been reading your CV, and I sort of sat here thinking, I don't know where to start. You are amazing. Yeah, everything you've done is amazing, and it's going to be such a good. It's going to be so good to get to know you and your path and how you got to the pathways that you did. Now, you received your mechanical engineering from Darmstadt University of Technology in Germany. You then went on to your master's degree in mechanical engineering from Cornell. You did your PhD at Cambridge University, and you've completed a graduate certificate of tertiary teaching and learning at RMIT University in Melbourne. So when you're at school deciding, what am I going to do with my life? What was the catalyst for your choice to be a mechanical engineer?
It's a really good question. And I just want to point out, in hindsight, things always looked like I had everything under control. Everything was planned. Nothing was ever like that. So I just want to put it out there. I'm not a great planner. And a lot of these things kind of happen because I decide to take an opportunity. So maybe going back a bit then as to why I decided to study engineering, because that's coming up a lot as a question. Honestly, I just couldn't make up my mind. I couldn't decide if I wanted to do math because I really liked it. I couldn't decide if I wanted to do chemistry because I liked that too. I liked physics. And so at the end of the day, I just decided, well, the best way to tackle this problem is to study engineering because it combines all those aspects in obviously the undergraduate studies. And I thought, okay, I get to do what I really like later on. I can decide later on which of these areas I really like the best. So I think it was more like, I didn't really quite know what to do. Engineering, well, Germany obviously is a fantastic industry environment for mechanical engineering. There's a lot of opportunities. And I also had a friend whose father was a mechanical engineer. So we actually talked to him a bit about it and kind of made the decision that way. And in hindsight, I'm sure I would have had fun in all the other subjects as well, but I'm really happy to have studied mechanical engineering and work in that field.
Well, yeah, look, we're going to get into all the different fields that have led you to where you are today. But you have such an impressive work history. What was your first job from university? I'm trying to step through how we get to where we got to, where we are. So what was your first job?
So jobs, I've obviously had quite a bit of a research career, but I've always tried to keep that research very industry focused. So as an engineer or as a student doing engineering in Germany, you have to do quite a few industry placements, much more so than the students actually do here. So we had to complete 26 weeks of practical training, some of that before we even started engineering, hands on the tools, and then several industry placements throughout. So I can't actually say that I've ever had a proper industry job because I haven't done that, but I've worked with a lot of industry clients and industry partners. So that either as a student working in that environment or later on as a researcher working with industry. And that has always been really important to me. I didn't want to be this typical academic that has, I don't want to say typical academic. I didn't want to be an academic who doesn't understand what industry actually needs, because engineering is so focused on industry. that I quite purposely chose jobs that were aligned with industry and working with industry. So my PhD, for example, was with a company, TWI, the Welding Institute in the UK. So I had lots of interactions with them. Then when I did my postdoc, we missed the postdoc in Denmark because I did that as well for 3 years in those little scenarios where I've been in the world. And that was with a company called Allen Glassfiber that does massive wind turbine blades and ships those around all the world. And yeah, so looking through, there's always been a lot of industry contact. And as I said, that's very important to me as an engineer, to have that feeling and understanding of what our industry clients actually need and how we can bring what we do at the university closer to the industry and create an impact that way.
So in essence, having to have that hands-on experience at 26 weeks, you could actually do that in different countries, but that also opened up a whole new world of contacts and networks for you as well, wouldn't it? As a student, that would have been an invaluable place to be.
It is. That's completely right. It is completely invaluable. And I even see that nowadays. So if we look at Griffith, for example, Griffith does the work integrated learning requirement. Mm-hmm. Yep. So our students go to industry partners and work there with their industry placements. And more often than not, they will actually take jobs at those companies. Yeah. So I can really only encourage any student to give it a go and apply for various industry placements throughout their studies, because the only way you know whether you like something or don't like something is actually by giving it a go and trying it out.
Absolutely.
And understanding that you don't like something is as important as finding out what you actually like. So the two things are really invaluable, and network building, we can talk about that more in detail. Again, to me, is an absolutely incredible tool, and it's one that I've used throughout my career all the time.
So as a layperson, mechanical engineer, to me, it can be a whole raft of things, can't it? But you've actually done, you've got over 160 journals and conference papers, which you focused on wind, naval, O&G offshore, and aerospace structures. So that's like a very broad spectrum.
It is a very broad spectrum, but there is a common component. So I specialize on materials.
Okay.
And on material performance and understanding materials, understanding what is the best material for a specific application, what is the best manufacturing process that goes along with that material, and how can I optimize this whole process chain, so to speak. So how do I find the right material together with the right process to make it the best for a certain application? And what that application at the end of the day is, whether that is wind energy, aerospace, all these industry sectors have certain requirements that are critical. Mm-hmm. So if we take, for example, any kind of transport, it's normally the weight and, of course, the performance. In other cases, it might be temperature. So if we talk about wind, there's obviously harshness, there's corrosion in a fairly ocean closed environment. If we talk space, then we have temperature and radiation. So the material requirements change all the time. As long as you understand materials, you can design for a lot of different sectors. So while it sounds like I've done a lot of different industry sectors, and that's true, I've worked with a lot of different companies, my expertise is specifically in understanding the material performance.
So then that now brings us to your current role as Director of Adapt Institute. And so I can see where what you have done in your history, in your past, has absolutely set it up for Adapt. So firstly, let's talk about Adapt. Now, for those who haven't actually heard of it or have heard of it, but want to know more, can you give us a bit of an overview of Adapt and what it does and who it is?
Sure. So let's start with a name, because it is a bit of a mouthful. So ADAPT is short for the Advanced Design and Prototyping Technologies Institute, and it is a facility that is led by Griffith University.
Yes.
Now, we focus on advanced manufacturing, not just on the manufacturing aspect, but really on the full start to finish of how a product is actually created. And we try to do this as much as possible in a virtual environment. Now, what do I mean by that? If we think about traditional manufacturing, this is all about potentially standing on a lathe, having a drawing, and actually performing that. If we talk nowadays more about advanced manufacturing, we're starting to create the models on the computer. We optimize the models on the computer. Again, what do I mean by that? This could have various aspects. So we know what the product needs to do. So we try to find, as I say, the best material, the best design, and we do that all virtually. And once we have that design, it can, in the case of 3D printing, for example, go directly from the computer to the machine. So the computer says, this is my file. That file gets read by the 3D printer. And for those that don't know that much about 3D printing, it is, in most cases, a layer by layer process. So what the computer does, it takes this, can be very complex design, and it says, okay, I will interpret that as a layer at a time. I basically cut it into lots of thin slices, and then I print this. So the printing process can be in various forms. It can be metals, it can be polymers, ceramics. We even have a concrete printer. And we basically say, okay, for each layer, and they're incredibly fine, so in the order of a human hair, we actually say, okay, what is that cross-section of this layer that I now need to create? And it can be a heat source like a laser that actually melts the material at that position, or it can be a light source that basically shines like a screenshot as like a camera, really, on which pixels you want to have cured in that case. And that way, layer by layer, we create our 3D object. And this object can then, of course, be a lot more complex than something we can get from our traditional manufacturing processes. So at the end of the day, you then have an object where you've actually never had to take a pencil in your hand or anything like that. It's all created virtually. It's optimized for its purpose. It can be very personal or specific to a certain task. Say a person, we do a lot of things that are patient matched. So you can take scans from a person and use those to then create the right tool for that person when it comes to medical devices. So it's incredibly versatile. It is, of course, the future of manufacturing. It doesn't mean that traditional manufacturing process will not be needed. It's complementary to that. It's still a fairly expensive process. But we at Adapt, we are working with local industry clients to get those new processes basically recognized, accepted, understood, so that we can actually help promote them regionally in Southeast Queensland. And then the amazing thing about Adapt is that we're not just engineers. So we're actually truly multidisciplinary. We are centrally facilitated by the university. We bring together all these academics that work at the university. They come from the health side. They come from the big data analytics side. There's people that know artificial intelligence. We try to bring all these things together with the engineering concept and create, as I said, this multidisciplinary environment, which I find truly fascinating. And I'm just so happy to work in.
Wow. It sounds amazing. And I'm going to, okay, so there's a couple of fields. There's the medical field and then there's that manufacturing field, isn't there, predominantly? So in the medical field, you're actually leading some current work in world first personalized digital twin research. Is that correct? And can you outline what that is in layman terms? Because I read it. I didn't write it, guys. I don't know what it is. I just want to sound intelligent. So can you tell us what it is? Like, what is it in the medical research that you're doing that's, well, that's making changes?
Yeah, so again, it's a really, really fascinating field. So I have to say, I've worked in all these different sectors, and until 2 years ago, when I came to Griffith and started becoming involved with Adapt and now lead Adapt, the medical side is the one that I find most fascinating in my engineering journey, but it's also the one I've been exposed to the latest. So why is that? First of all, it's because Griffith is actually quite special in the way we are located right next to the hospitals. We have surgeons that actually come to us and work with us and want to drive change. And that makes a massive difference. If you have that medical profession come and say, hey, engineering, come on, get your act together. We actually need help. And we want to make something. So that's the one side of it. So medical, what does that then mean? If we talk about a digital twin, you actually had a podcast in the past with Duncan who was talking about what Myriad does for Griffith. And that is one part of it. So we can basically take a human and measure this human up and film this human and then put them in this virtual environment and say, okay, what is now actually happening? if we know the movement of the person, if we know how the person walks, if we measure all these things, we have sensors that we can put on people, we can make people walk over force plates, as if we film them as they're walking. We can actually understand how their skeleton and their muscles work. Mm-hmm. And we can use that information in computer programs to figure out, okay, what is that person doing if they have a problem now specifically on a joint? What is happening at that specific joint? And potentially something is not quite right, misaligned. We focus a lot on pediatric surgery. So again, this is for children now. We can take scans of children. We say, okay, this is something that needs to be corrected. It can easily be corrected surgical, but we can lead to better outcomes if we actually plan all this in advance on the computer. Because on the computer, we can make changes. So say, for example, you have a hip bone that is misaligned. And you say, as a surgeon, you go in and you have a lot of experience and you say, yeah, I think I need to correct this by 5 degrees. And they do it on the spot. But on the computer, we can plan this and we say, okay, if you do this 5-degree cut and realign things, what is then the motion after that? How does it work? Are we getting the right result? And we can fine tune basically. And then we go a step further and we say, okay, now that we've figured out how you want to fix it, let's actually help the surgeon by producing tools that they can use during the surgery that are really specific for this person. So this is what we call a surgical guide, where we say, okay, this is exactly the bone shape of the person, and here's what we want to cut, here's what we want to align. We create a guide just specifically for this person. We've tested it on the computer. We then print it. That happens at Adapt. And we measure it all up afterwards, make sure it's the right fit for the person. Then it goes to the hospital. It gets sterilized over there, and then it gets used in surgery. So this is not something that stays in the body. This is something that is just used during surgery, and then it gets discarded afterwards. But it helps a surgeon, as I say, with the alignment. It can potentially help a more junior surgeon to get trained better in the process, make fewer mistakes in the process, or just be more accurate. I don't want to say mistakes, actually be more accurate during the surgery. And that is absolutely amazing. So we have to date supported over 30 pediatric surgeries in that field across various hospitals on the Gold Coast in Brisbane. And it's just fantastic impact. So there's 2 of our staff that lead this. They've had, it has a lot of impact, and we're just so happy to be able to support those kind of projects.
So Stefanie, have we got to the stage now where if you need a hip replacement, that we can purpose build the hip joint to the person? Have we got to that?
So we're closer. Okay. So the first answer is yes, we can do this. Where things are a bit on the conservative side, and that is a good thing, is that the Therapeutic Goods Administration, so TGA, is actually, and so is the FDA in the US, they're paying a lot of attention to the fact that new technologies introduced in medtech need to be safe. So as advanced manufacturing or 3D printing is still, honestly, a fairly new process, a lot of industry sectors are still going through the evaluation. So we hear this all the time saying, okay, is this part as strong as something we've cast, that we've machined? And generally the answer will be yes, but the database that we've had a lot of time to build up over years, of course, with other manufacturing processes, that currently does not yet exist for additive manufacturing. So in terms of getting an accreditation to say, yes, you can use this in a person, that is still a very complex process, and it should be. So we don't want anybody to just be out there printing things and then saying you can put this in a person, because if the process goes wrong, it doesn't get properly supervised, the machines don't get properly calibrated. There's a lot of little items that have to fall into place. They need to be regulated.
But so, it is the future, isn't it?
It will be the future. I think things will go away from one size fits all, or a few sizes will fit many, to, yes, we're doing this specifically for you. Yeah. And the costs will come down, and this is what will happen over time. So it's quite amazing. So, I only learned this, as I said, over the last 2 years. If you get a hip replacement, we actually don't like to do this for patients that are too young, because the hip replacement has a lifespan of generally about 20 to 25 years. So if you do that for a person that's 50 and generally not that active anymore, that's fine. If you do that for a person who's 20, by the age of 45, they will probably need a replacement. And The metal parts at this point are still a lot stronger than the human bone. So what's basically happening, bone is a very smart material. It actually looks at this and says, okay, you've got something there that's pretty strong. So do I actually need to be here? And therefore, over time, moves away and redevelops and actually becomes thinner around the implant because the implant is stronger and stiffer than the bone. So if you then want to replace this, the next replacement will have to be a bigger implant because the bone around that implant has been weakened. And that is just something that we can do once, definitely, twice maybe, but we generally don't like to do it too often because it's causing problems. If we can make it patient-specific and patient-matched, these kind of problems should stop in the future because, as I said, we will make sure that it's much closer to bone itself and therefore becomes a better structure to be integrated and potentially later replaced as well. So there's a lot of fantastic advancement coming in that sector, for sure.
I was going to say that because one of the most fastest, quickest growing sectors is that medical sector, and I can see the ADAPT being really formative in pushing that forward. I mean, we're talking artificial hearts, aren't we? And we're talking potentially limbs, and we're talking about. I think you work with Hal Rice on doing. And do you want to explain that one a little bit? Because that was just amazing what can happen there as far as brain aneurysms are concerned.
Yeah, so Hal is amazing. So he's building this training center in the Gold Coast Health and Knowledge Precinct, where they're looking at later on robotic surgery for brain aneurysms. But again, there's a big training factor. So if you actually use these really highly specialized techniques, ideally you want to practice this before. So what we can do is we can scan the patient, we can isolate the aneurysm in the brain, we can take that part and actually print it at ADAPT. And then there's specific equipment where you can actually simulate how liquid would flow through this aneurysm and pulse, so that when they then plan the surgery, it actually feels, and they actually perform the surgery, so to speak, on the scanned aneurysm. So they know exactly how to guide the wire into that right location. As I said, again, we can do training for more junior doctors, for international experts, to train them in the latest procedures. It is absolutely amazing what can happen in this space. And again, it's all patient targeted, and we know exactly what that patient aneurysm looks like before, and we can use that information from scans to, as I say, print a model and then have the right training tools.
And the advances now, and we'll move over to the manufacturing side. So the advances in manufacturing are going so quick now. And I think one of the things that impresses me about ADAPT is that multiple metal and polymer and you said ceramics and you said concrete, and I know it's Inconel, is it, which is that high temperature resistant metal. Now that particular metal is being used in satellites, is it, or rockets?
Yeah, so again, it's the right material for the right purpose, right? So if you're sending something up to space, we have a lot of temperature fluctuations up there. So facing the sun, it will get very hot. Away from the sun, it will then get very cold. So you have to have materials that thermally behave in the best way. So it's not always then the lightest weight. It's about the thermal performance. And Inconel, you're quite right, is one of those materials. So when it comes to 3D printing, we have a specific metal printer. The metal printer uses a very high source laser power to melt the material. So we can put a wide range of materials in there. At ADAPT, we focus on Inconel for the space applications and on titanium for implants because it's a biocompatible materials. But we can also do aluminium, we can do stainless steel. So the machines are nowadays very versatile. What you need to change when you use a different material is you need to adjust the power of the laser and the speed with which you operate, because each metal behaves slightly differently in terms of its melting temperature. But generally, the technology has moved on to such a state where we can print a large number of materials, on the metal side, but also on the polymer side and on the ceramic side. So all the technologies work in a similar way coming from the computer file, but then the specifics on how you operate the machine, that still requires very specialist training and expertise. So the technology is not at the point where we just stand there and press a button and come back the next day and say, hallelujah, here's my part. It really requires a lot of knowledge in terms of operation. There's a lot of training. And at ADAPT, we also train our undergraduate students. So we get about 12 students a year that do their projects with us and sit there and observe. They don't operate our equipment because, as I said, we have technical staff to do that, but they certainly get exposed to the workflow and how 3D printing works and how you design for 3D printing.
So can you give us an example? We've got some medical ones of that manufacturing world and where ADAPT can assist in that manufacturing, with industry.
Yeah, so on the medical side, that a lot of the kind of prototyping. So we're not here to produce 500 parts. We're here to actually show that something can work. So as an examples are the surgical guides we do. Examples are the aneurysms we're working on with HAL. We've worked on some implant designs. Again, those kind of things we can then take to animal studies. We can take them to cadaver facilities. So we have a cadaver facility at Griffith that is linked to a 6-axis degree of freedom robot. So prior to doing human trials, there's a lot of steps that you have to go through, from making sure the material performs as it should, making sure, the company says this is biocompatible, you can use it. For implants and so on, I know animal studies, that's not everyone's favorite topic. But again, we need to make sure we're safe. So there are certain rules and regulations and steps you have to complete if you actually want to bring a new implant onto the market. And then the cadaver studies are really, really important. So as I said, we have a robot where we can potentially put a limb into it and put the implant into that limb and make sure it actually performs properly after the surgery has been done. We're also working a lot, again, on what we call phantoms of humans. So we don't want to use animals. We don't want to use cadavers unless absolutely necessary. So we actually try to come up with ways to make human phantoms by using the right engineering materials to basically 3D print these parts. So then we can put that into the robot. So we don't need the animal as much and we don't need the cadavers as much. So there's a lot of stuff, again, happening in this space to make sure that advanced engineering can create an impact and obviously eliminate some of these steps that we don't want to use too much.
And for companies like, I think Gilmore and other companies that are out there, how can they benefit from ADAPT? What would be that link between those really advanced manufacturers that we have out there and ADAPT, and how can they take advantage of that?
Yeah, so primarily ADAPT is actually, our first role is to serve industry. Yeah. So that's, even though we're located in an industry environment, and then we have various mechanisms. If it's just something really small, you can just come to us and say, how much would this cost? Yeah. And we can print that. But that's not really where our value is. So our value is more in somebody coming to us and say, hey, I haven't used 3D printing. Do you think this would actually work for us? Because a lot of 3D printing houses, you can just send your parts in and they will send it back to you and say, here it is. So
Stefanie, we've talked about medical and the medical technology and how it can advance medical technology and support, the growth of that industry. What about the manufacturing side? What about the advanced manufacturers out there? How does ADAPT link with that, and how can manufacturers and ADAPT form partnerships that are conducive to business, I guess, or to that industry and support that industry?
Yeah, thanks, Estelle. A really great question. So first of all, ADAPT is primarily there to serve industry. That's our first mandate. Of course, we do research support as well, but primarily we want to help local businesses become more advanced in manufacturing. And then there are a lot of different ways we can do that. So if you're just interested in printing a part and testing performance, we can easily do that for you. You can come to us, we print this for you, you take it home, you try it out. But I see value more in the interaction with industry and actually training industry, because we are a university facility. So as such, you can come to us. We actually talk you through the 3D printing process. We help you understand how you should design your components to make the most out of the 3D printing process. We tell you the different possibilities, whether it be on the polymer side or on the metal side. There's a lot of different technologies. What's the most cost-effective of those? Actually, whether your part is suited to 3D printing in the first place, it might actually not be a cost-effective solution. And then if, as a company, you decide to want to go down that path, again, we can come to various collaborative partnerships. So We've had it in the past, long-term collaborative relationship with Gilmore, for example. Gilmore we would basically have some of Gilmore's staff come to us and work with us. We would train them on our equipment so that they have a really good understanding of whether this is now something that they want to include in their business. And if then the answer is yes, and that's the case now, they go and buy their own printers. PWR has done the same, for example, on the Gold Coast. So yeah, it's a really good way to come in, and rather than invest, and this is big money we're talking about, a metal printer costs $1 million. The infrastructure to actually house the powder, to hook up the metal printer is another $1 million. And then you need 2 people that would actually run this printer, just to have, obviously, staff that can operate it. So this is a big undertaking. You don't want to take that step lightly. You actually would want to come, I think, to a facility like ours and really get all the answers, work with us, really figure out if this is something that benefits your business, and then make a very informed decision. And we are happy to work with industry partners in that manner and provide that training.
Stefanie, it's really interesting to hear the materials that you can print in. And a couple you mentioned were ceramics and concrete. Now, what do you make out of 3D printed concrete? Sounds like a grand idea, but what's the usage for it? How do you utilize it?
So concrete 3D printing is really nowadays used to build houses, if that's what you would like to do. The shape that you can print in, of course, can then become a lot more fluid and organic. It actually is a very sustainable, or more sustainable technique, because it saves a lot of these extra building materials that you would normally need if you build in concrete. So concrete needs to be reinforced, right? It's all about pouring concrete into a specific cavity to begin with. Now, if you 3D print it, the material is slightly different because it sets a lot faster. So basically, it self-supports as you print, and you can build up full structures out of this. So that has already happened. It's still a lot about the right material research.
Yeah.
Now, I'm not a concrete expert myself. One of my colleagues, Dr. Doe at Griffith, is, and it's all about the right material formulation, because we want to make sure that this material can, A, be more sustainable. So we're looking at fillers that we can put into these materials to actually potentially take up some plastic waste. So this is a project that's very close to my heart at this point. Or other materials that we can put into the concrete. So I said, to reduce its footprint, and then also reduce this overhead that traditional concrete pouring produces, a lot of waste material that gets used in that sense, and that we want to eliminate in the manufacturing process.
Wow.
But yeah, ultimately it's basically an automated concrete laying machine that can run on a gantry system. It's just controlled, and say, if you want to build walls for your house, please go. You just have a very, very long arm that obviously is computer controlled, and then puts the material where it's needed.
That's amazing.
So there's some great videos on YouTube. Everybody who's interested can Google and can have a look. I think it was even used on the block in Australia in one of the past seasons. So yeah.
Well, I'll have to. We'll put all the links down underneath your podcast. That sounds amazing. So I can just get a house built out of concrete. What about ceramics? What are we building out of ceramics?
So ceramics, again, really fascinating material. There's a lot of application for health and medical, again, because it's biocompatible. It's in its material properties actually very similar to bone. The only thing we're dealing with on the mechanical side right now is that it's also very brittle. So what that means is if it fractures, it, like glass, it breaks into lots of little pieces. So from a fail-safe point of view, it's something that the medical industry at this point doesn't like to use as such, because we're concerned if something goes wrong, that this would be very detrimental to the person, obviously, who has such a ceramic implant potentially. It gets used a lot of defense, satellite communications. So there's a lot of heat shielding for any kind of incoming rockets for re-entry and so on, because it's really high temperature resistant, so much higher than any kind of metal. We can go to above 1,000 degrees. So all the heat shields on re-entry on any kind of rocket or space shuttle are all ceramic.
Wow, I didn't know that. So Adapt, it's amazing we've got it right here on the Gold Coast. So Adapt is the future, isn't it? And how can industries engage, and at what level should they start having that conversation with you if they're looking at maybe doing some design work or prototype design?
So as the director of ADAPT, I will be very clear on yes, ADAPT is the future. The university remains fully committed to building ADAPT 2.0, which will be integral as part of the Gold Coast Health and Knowledge Precinct, which in its vision at this point will co-house industry partners with our technicians to basically work on translating that technology. Because as a university, we're of course academically focused, but we're trying to reach out and translate. So we also need industry partners that are very open about new ideas and are happy to take some measured risks. But as I said, not just use the status quo, but actually say, hey, how can I expand further? How can I make a difference? What if I change this? What will that mean for my consumer base? And there's a couple of those, there's quite a few of those companies on the Gold Coast. It is quite amazing what we have in terms of manufacturing and the collaborations that we're in, as a discussions we're entering into. And I would say there's never a wrong time to actually come and see us. Any company that is working on manufacturing can come to us and just have a look as to what 3D printing can do and how they could potentially utilize it in their field. So we do a lot of tours for companies and do industry outreach. So always happy to accommodate and our technical staff. So as I said, we have dedicated technical staff. I currently have 3 production engineers. Yeah, we're always happy to talk and basically build that dialogue and just help facilitate that knowledge transfer.
That's excellent. And again, I'll put those links underneath the web, the podcast. Now, coming back to work-life balance. This has been a big subject, hasn't it? It's like a really big subject post-COVID. How do you are such a busy woman, like you are just like this phenomenal, researcher, scientist, and you're also a mum, I think. How old? You've got a son?
I do have a son, Byron. He's 12 years old.
12, so you got
he has a lot of energy.
And you've got a dog that we heard a little bit earlier. How do you get your work-life balance? What's your tip for work-life balance and being a working mum, which is what you are?
Okay, first of all, I have a very supportive husband, which is absolute key. So we both work. He's an international lawyer. He travels a lot, actually. So there's a lot of sharing in the household involved when it comes to the daily activities, school drop-offs, manage that. And ultimately, the thing is about work-life balance. I'm passionate about what I do. Yeah. I get a lot of energy from it, so it never feels like a chore.
Yeah.
Whether I have enough time for myself, well, that is how do you relax? I often actually relax while doing work. And that sounds horrible, but as I said, I get a lot of energy from it because I see that impact that we're creating. And it just makes me very excited. So my job is never the same day to day. And as I said, so many exciting things happen. For me, the biggest problem is when do I say no?
Yes.
And because there's all these fantastic initiatives and I want to be part of them and I want to make sure that we can actually progress these fantastic ideas. And there's beautiful initiatives from Griffith that we're supporting. And so it's more like, okay, how do I prioritize? And at the same time, also, how do I make sure there's enough time for myself and take care of myself? Yeah, it's a lot of planning involved, as I said, and a very supportive and engaged family in the process.
And I think it's two ways, because I think I was reading that you said that you go home and you share your research problems and insights as a great part of your day with your son, so much so that he wrote a school assignment that says, my mum tells me interesting facts every day. So there is that whole part, isn't it? I mean, it's about engaging the whole family, being part of that whole team. That's what it is, isn't it?
That's right, because I sometimes feel, honestly, very guilty about talking about work a lot. And to hear comments like that is then, of course, very, very uplifting when my son actually acknowledges that the work we do is inspiring. And he has obviously certain ideas about what he wants to do in his life. He loves cricket. He wants to be a famous cricketer. And but he also wants to have a PhD and be like his parents. So it's very interesting. And I was like, just really nice to have that ability to share exciting things from the daily work with the family.
And so you and your family now call the Gold Coast home. I say now, but your husband actually grew up on the Gold Coast. So what is it about the Gold Coast that makes it special to you and your family?
So he did grow up on the Gold Coast. We honestly never expected that we would live on the Gold Coast. So we started, when we came to Australia in 2005, we were in Melbourne for 10 years. We left Melbourne in 2014 to move to Singapore for 7 years. And we were there, which was fantastic while Byron was a very small child. And it was just closer to my family in Germany to be able to see both grandparents across the world more easily. And then during COVID, well, we had to make this decision saying, okay, what do we want to do? We're quite isolated in Singapore. We couldn't travel. And that's when we made the decision to move back to Australia. So coming to the Gold Coast, I had visited before, but I have to say I'm loving living on the Gold Coast. It's the best climate. It's the best weather. It's easy to get around. And Byron is loving his school. So just to see all these outdoor activities again that we can do every day, and we're actually quite a sporty family, that is just the best part about living on the Gold Coast. Yeah. That's what I would say. Get up early, do exercise, be out and about. I don't know, there's cricket on Saturdays. There's all these activities. After school activities for Byron. So I've seen such a big change for him coming back here to a sporty environment compared to Singapore, which was brilliant and safe, but at the same time quite sterile and not so much focused on outdoor activities. So I think that is just so important for children growing up to have that opportunity, and the Gold Coast offers all that.
Thank you. And it does. And I totally agree with you. Best place in Australia. So look, thank you so much for taking time out of your busy day to speak with me. It's been absolutely amazing to talk to you. And anyone who's interested in learning more about ADAPT, definitely, contact. And as I said, I'll put the contacts underneath and go and speak to you and your team. But thank you so much, Stefanie.
Thank you very much, Estella. It was my absolute pleasure.
Thank you. Thanks for listening today. For a complete list of podcast episodes and transcripts, go to rdagoldcoast.org.au/podcasts. And don't forget to follow us on Facebook, LinkedIn, or Twitter.